Hey there. You've now written quite a bit of code with hooks, so let's explore the second main question of the course, how the React engine and hooks work under the hood. First off, React is often defined as a JavaScript framework that takes care of the UI for your application. Now, indeed, React manages the UI for your app, but as a framework, it does so much more than a general UI library. React is an entire runtime. So as a runtime, the React engine is this system that continually outputs a tree of nodes that represents the structure for your application. This tree of nodes changes over time, and in the browser, those nodes translate to document object nodes that can construct HTML. So the eventual output of the React as a runtime is an entire document that represents the web application. The engine itself can react to external events like user interactions, network responses, or timers, and React will adjust that tree of nodes so that way the document updates with the added elements or elements removed based on the expected responses to those events. So how are those nodes constructed? Well, one of the JavaScript DOM nodes can be created right in your browser by entering this text. So const node equals document.createElement of div, node.innerText equals hi, and then if you log that node, it's going to be a div with the content of hi. So the createElement function returns an object that represents a document node by using the document core API provided by the browser's JavaScript environment. Now, even though you're not writing this code when you use the React framework, the React engine eventually writes this for you. It calls createElement and other functions from the DOM API in order to translate React component code into updates of document object nodes. For example, say you wanted to render a paragraph element with a text of hello using React. In this case, we're targeting the element with the ID of root within the document. Well, under the hood, React would translate this to core DOM API code that essentially looks like this. First, the P node is created, then that node's inner text is set to low, and then finally that P node is appended as a child to the root div. Now at this point, React is effectively working as syntactic sugar around the core DOM API. You might as well have written all this DOM code yourself. But all the same, the result is an HTML document where at the root div, there's now a paragraph element with the text hello. All right. Once you're here, this is where the magic of React happens. Now that there's this HTML, say you wanted your React app to now render another paragraph element. This time, the text is going to say hello world. And now it's still going to attach to the root node within the document. Consider that the HTML already contains a paragraph element at the root div from the last render. Well, given this situation, there are essentially two approaches that the React runtime could take. It could essentially decide to nuke all the content of the root div and then recreate the nodes from scratch. So it would set the root div's inner HTML back to an empty string. Then it would recreate the P node, set the inner text to hello world, and then append that as a child again to the root div. But the trouble with this approach is that using the DOM API is expensive. You want to minimize your DOM operations if you want your web application to be performant for your users. You especially want to minimize the creation of DOM objects since this operation is particularly slow. On top of that, you lose important state, such as the element being focused on and highlighted within the DOM. In this approach of starting from scratch every time, React would be recreating hundreds of DOM objects at every single render, causing significant load. So as an alternative, React doesn't go through this process. Instead, React does a process of reconciliation. In this process, React decides whether to update an existing node or to create an entirely new one. First, it has to identify whether or not the targeted node can be updated. So in the second React DOM.render, where we want to create a paragraph element with the text of hello world within the root div, first React checks through reconciliation, is the root div's child already a paragraph element? In this case, the answer is yes. Therefore, instead of having to destroy that existing node and recreate a new one, React knows to call the more efficient setter of the inner text. It calls pnode.innerText equals hello world, and there you go, the DOM and application update. Therefore, React doesn't need to blow away the contents of the root DOM node you're already inserting into. It can efficiently update the existing child. But this only works if the element types are the same. To extend the example, say we want to render a form within the root div now. Again, React asks, is the root element's child already the same object type as what you're trying to render? In this case, no, it's not. So it discovers that the child is not a form, but a paragraph element with a text of hello world. So it removes the existing child node of the root div. It creates a form node, and then that form node is appended as a child. So overall, as your React app is updating, the runtime is checking whether or not existing DOM nodes can be efficiently used with updates, like in the case where we re-rendered a paragraph element, or whether or not entire DOM nodes need to be created, like in this case where we're inserting an entirely new element. By the way, this explains why React reminds you to always apply keys to your JSX elements when you map them out in a list. Usually, comparing the element type is enough for React to understand whether or not a node should be updated or reused. When it comes to a list that has dynamic content though, within each list, React still needs a way to uniquely identify each sibling node individually. In other words, it needs a way that it can still do reconciliation. That way, it isn't forced to run an update on every single node when the list is reordered. Instead, React can still use the existing DOM nodes in this case, since now keys are attached to each node across consistent renders of the application, even if the list is reordered. Okay, that covers the output of the React engine itself. There is also the structuring of a React application to discuss. In your React code, all the components are functions, but this implies that you could technically call your React component functions and have them return React elements yourself. So you could certainly say, let React component equals, I'm going to call the app component function, and then you could try to insert it within the DOM. But we know this is not the syntax that is used. You don't directly call the component function. Rather, you let the React engine call your component function for you. Instead of calling the app component function, you specify that you want a component to render through the JSX syntax. This special syntax is recognized by the React engine, and it gives the React engine the power to call your component functions for you. Again, with JSX, you're not really calling the component function. Instead, you're specifying a syntax which hands over the control to the React engine to call your component function on your behalf. So this is an example of the programming principle of inversion of control. It's a powerful concept because by handing over the responsibility to React to call your React component functions, it can do some really cool things. The first of which is that React can recursively call multiple nested components if you provide a nested JSX structure. Say you have an app component that within it has a header component as a child. So you're not in charge of calling the component functions to build out the overall structure. React is. So under the hood, React will first check what the app component returns by calling the function. The app component returns an overall div with a header component as its child. So then React checks what the header component returns by calling that one as well. This returns an outer paragraph element which has its own child elements, header 1 element with the text of welcome, as well as some more text. And now React has finished its recursive calls and then returns an overall DOM structure of a div with an inner paragraph element, the relevant header 1 element next to some text. So the key takeaway here is that you're not in charge of calling the React function components. Instead, React itself is in charge of calling the function components under the hood. In this pattern of inversion of control, React is determining which components need to render to create the necessary DOM structure for your app over time. In addition to having this ability to recursively call your component functions based on your JSX structure, React can achieve other cool things with the control over your components. Since React is managing the components, it can augment each function component with features like state, so that the component can have its own local data. It can do things like tie side effects to the rendering of your component, which may include things like fetching data. And the API to augment your functional components has become React hooks. Under the hood, React will attach state to your component when you call useState. It will also attach side effects to your function component when you call useEffect. Ultimately, understanding this model of inversion of control is key to understanding how React hooks work under the hood. With the ability to recursively call components and to augment your components with React functionality through hooks, that is where the React runtime gets its power. Overall, this is how the React engine works under the hood. It translates your component code into DOM updates. It also has the ability to efficiently call your component functions to build your application structure. With control over the components, it can augment them with state, side effects, and other useful features. With the rest of this section, we're going to continue to focus on this question of how hooks work, with narrow investigations of how certain hooks like useState actually keep track of the data for each component. Some of the behavior can seem quirky, so it's important to explore that quirkiness to eliminate any confusion. All right, see you in the next one. Hey, if you're enjoying this content, be sure to head to the full course at udemy.com/reacthooks tutorial. Since you're coming from YouTube, I'm giving you access to the course at the max discount Udemy lets me create. I've posted details in the video description, and be sure to visit my website at davidtkatz.com as well, where you can find links to connect with me. All right, see you in the next one.